Hello, this is the Chapter 6 lab, and I wanted to provide a little tutorial here for you to kind of go over some of the concepts so you won't get confused on this lab. The Chapter 6 lab is applying concepts of absolute humidity and using a table of absolute humidity values, showing you how at differing temperatures how much water can be held in the air per kilogram in grams. And the table isn't directly used for answering specific questions on the lab, but you do reference it to some extent for some of the questions just to apply concepts with relative humidity and dew point temperature. Just an important concept to reiterate, as air temperatures go from very cool to very warm, notice the ability to air to hold more water vapor and higher levels of absolute humidity. That's why on a warm summer afternoon, the potential of air to have higher humidity is so much higher than a cold winter day, potentially in central Illinois. So we use this table specifically when we get down into question set 1, and question set 1 and 2 really reviews the video here on weather balloon data. And you're going to be looking at two specific weather balloons, and I'm clicking on the video here to load it, and I'm going to turn off the audio. Well, this video here really isn't here to help you in any way to specifically answer any questions, but it does show you nicely how weather balloons collect data and how they collect, in particular, as a balloon floats up through the air, the instrument package attached to a weather balloon. And that instrument package is where our data comes from this lab. So this is just a nice little video to show you where the weather balloon, where the data comes from for the lab. And you're basically going to be comparing Lincoln, Illinois, and Newport, Virginia. And Newport News, Virginia is off of the East Coast, and obviously Lincoln, Illinois is in the Midwest. And what you're going to be doing is you're going to be comparing and contrasting radiosonde data over on the same date and trying to understand why the weather is so potentially different in Lincoln, Illinois versus that of Newport News, Virginia. And these little text files here are the actual data you'll be using to answer the question. So if you were to click on one of the text files here, and I'll do that here in a second, I'm going to open up a file here. This file here shows you specifically the air pressure as the weather balloon takes off, and this is the very first reading here. And at Lincoln, Illinois, it shows you the weather balloon started off at 154 meters, and then the balloon, as it starts to float up, this is the height. The next column is the temperature of the balloon at that specific altitude in meters. This is the dew point temperature. The higher the dew point, the higher the level of humidity. And the key columns for this activity are the relative humidity, and this indicates how close the air is to being saturated. And the last column is the absolute humidity, or the mixing ratio in grams per kilogram. And very interesting to kind of lock in on is, notice as in Lincoln, Illinois, as the readings are going up in altitude, notice how the numbers never get above 50%. This is very powerful to tell us that on this date, the air was not close to being saturated, so the air was very unlikely to be condensing on this date. And this is one of the key themes of understanding the lab, is on any given day, over central Illinois might look very differently in terms of data compared to, say, some location of a coastline like in Newport News, Virginia. So as the lab opens back up here, it's a little slow. Here's the data, and if you look at the very first set of questions for Newport News, the questions ask you, for example, what altitude would you profile for cloud development to occur in the atmosphere? And I even give you a hint, on this date, no values exceed 50%. So when you're answering the question, I'm almost answering it there for you. On this date, basically the air at no altitude was even close to being saturated. It says at what altitude was the absolute humidity the highest and how much water was in the air. So all you have to do is find the absolute humidity column and look at what altitude had the highest grams per kilogram on that date and tell me at what altitude did that occur. And then the last question is a basic true or false question. At no altitude did the atmosphere get close to saturation. And that simply is just reiterating question A here on question set 1, that since no altitude, no relative humidity readings got over 50%, I'm basically saying the chance of cloud development, I'm saying at no altitude did the atmosphere get close to saturation. That's basically another way of saying at no altitude did the air get close to producing cloud cover. And so it was probably a clear sky day. On question set 2, there's just a massive difference in the data. And I ask you to really compare and contrast the data you looked at for Illinois and compare it to the location in Virginia. And what I'm really looking at is specifically as the data loads in here, look at the relative humidity column, look at the dew point temperatures, and look at the mixing ratios. When you see this data, look how the air is much closer to 100%. Look how the absolute humidity levels are so much higher. The dew point temperatures are higher. Look at how close the dew point temperatures and the air temperatures were to one another. These are all indicators that the air was much closer to being saturated. And when the air becomes saturated, that means that a condensation is imminent. So when you look at this environment on this day, what was the chance of cloud cover and condensation? Well, it's obviously going to be much higher than it was in central Illinois because the air was much closer to being saturated. So when you're going through these questions, you're not necessarily using, and I just stopped it. So when you're looking at question set 2, look at these questions in particular, like for example with B and C. What did you notice happening as the air became cooler at both Illinois and the weather balloon in Illinois and the weather balloon in Virginia? As the balloon rose and went up, what did you notice that happened to the absolute humidity column as the air cooled off? Also, what did you notice when the air temperature and the dew point were very close? When the air temperature and dew point were very close, what did you notice that meant to the relative humidity? This is very insightful to show you how you could use the air temperature and dew point are ways of telling you how close the air is to being saturated and condensing. And when you look at your data, in particular for Newport News, what was the key that you noticed that made the relative humidity data so different than that of Illinois? And so pay real close attention for the gap between the air temperature and the dew point. And when the numbers are very close, what are you noticing happening to the relative humidity readings? For question set 3, you're actually watching a video and trying to understand why are some clouds tall and why are some clouds flat? And you're looking at concepts of being unstable and stable. And this video here really outlines for you is the key themes of understanding is you're really looking at what's the temperature like inside of a cloud versus the temperature of the air outside of the cloud versus inside the cloud. So what makes a cloud tall versus a cloud flat? And you're going to be talking about whether or not the air cloud is unstable or stable, and what makes air unstable. And the key thing you should be looking at is as you watch the video, pay close attention to the temperature of the air inside a pocket or parcel of air to the temperature outside. And when the air is warmer than the air around it, like a hot air balloon, what does it want to do? And in contrast, when the air is inside is colder than the air around it, what does it want to do? And then what net effect does that have on cloud development and shapes? Question set 4 is basically talking about how do you get cloud development and rain to begin with from the get-go? And we talk about lift. All 3 questions are basically lifting mechanisms are what initiate and start the cloud development process. And this instructor here really foreshadows to you all lifting mechanisms have one thing in common. Is it about the air going sideways or going up? And if the air is going up, you should understand specifically why does air rising tend to lead to cloud development and rain? And it has everything to do with adiabatic expansion and how air cools. And as air lowers its ability to hold water vapor, and that promotes condensation and rain. So watch this video, pay very close attention to how air rising and expanding promotes cloud development through manipulating the air to become cooler. Cooling the air has the ability effectively to rob of its its ability to stay in the vapor form and forces it back into the liquid form, which is how we cause cloud development and rain. So these are just some hints here to how to understand the videos and use them to understand the questions. And hopefully after these videos, you should be able to answer the questions in the exercise.